Hello, my name is Cameron, and I am an honors student in the Psychology Department of Concordia University.
I am a part of the Concordia Social Cognitive Development Lab, run by Dr. Kristen Dunfield. Our main focus is on how children interact with, learn from, and evaluate people in their environment. Much of our research centers around the effects of social cognition, which is how children learn about and from the people in their environment, on the development of trust and the production of prosocial behavior in childhood.
In this short video, I will be describing the work that I did over the summer of 2020, which was made possible thanks to a Kusra Award. Now, the research that we do is inherently social in nature, as the interactions between people are the primary target of our research. The COVID-19 pandemic posed a serious threat to our ability to continue our work, as social distancing is not really conducive to social research, and masks are not really conducive to reading emotional expressions or individuating people. And so the project that I proposed had to be reworked. We decided that the best use of my time would be to develop strategies for migrating our research online. Essentially, I was to determine the best way to do socially distanced social cognitive development research.
Before the pandemic, Maxine Iannuccelli, a PhD student in our lab, had developed a thesis project which explored how different early social experiences influence developmental outcomes. The original research design required in-person participation from parents and their children. As we began to understand how long we would be living under COVID, we pivoted my research focus and explored best practices for the development and implementation of online experiments with children.
Thanks to the success of our efforts, we were able to launch this project, and we are currently in the midst of data collection. Because this video will be made public, and we don't want to bias any of our participants, specific details were changed or omitted in this video. The stimuli that you'll see in a couple of moments are not the ones that were actually used in the project, however they are very similar.
Transitioning this research online posed two main challenges. The first involved recreating the experience of solving a three-dimensional physical puzzle in a virtual two-dimensional environment. This is because the main stimuli that were to be used in the study were puzzles. Essentially, I needed to create online puzzles that would be as similar to the real thing as possible, that would create the same types of experiences that real-world puzzles do. The second involved developing a system whereby parent-child interactions could be observed and recorded for later analysis.
After trying unsuccessfully to find existing web services that we could use as our stimuli, we decided that creating our own website from scratch would be the best way for us to overcome our first challenge.
Thanks to many free online programming courses, and specifically W3 Schools, I was able to learn the necessary JavaScript, HTML, and CSS to design the skeleton of our website. This skeleton consisted of a number of instruction pages that displayed pictures and text that could be navigated by pressing buttons.
The puzzles themselves required a more in-depth knowledge of programming than what I was able to get from these free online tutorials.
Specifically, we needed to recreate the experience of manipulating puzzle pieces. This meant that we had to display images which could be moved to different locations and rotated such that they could fit together. I used a very useful JavaScript repository named JSPsych as a starting point. Created by Dr. J.R. DeLieu of Vassar College, JSPsych hosts a number of freely available JavaScript plugins that accomplish basic psychology experiment tasks. One of these plugins, named JSPsych FreeSort, allowed the user to load images of specific sizes and shapes which could be dragged around the screen with a mouse. This was perfect. Generously, Dr. DeLieu has allowed users to modify their plugins freely. I modified this plugin so that the puzzle pieces could also be rotated. Many other modifications were made to the plugin, including adding a timer, a continue button which ended the trial, and creating a system that would record all of the participant interactions with the puzzle pieces as they used them. At this point, we had a website which could display interactive puzzles for a predetermined duration and record participant interactions. Maxine provided me with the puzzle piece designs and solutions that she wanted to use, and I then formatted them so that they would display appropriately. This involved cutting each piece out of an image file using Photoshop and formatting the pixels to display correctly in the FreeSort environment.
There were multiple iterations of the puzzle piece design and the puzzles themselves as we gained a better idea of what 5 to 7-year-old children could reasonably do online. To jump ahead a little bit, once the website was operational on the internet, we ran a number of pilot studies. The information that we gained from these pilot tests was extremely valuable, and it led to a number of changes to the website's structure.
We increased the number of practice trials so that the children could learn how the website worked, and we also had to reduce the difficulty of certain puzzles.
Some of the children had trouble moving and rotating the puzzle pieces at the same time. So I developed some alternative control methods to try to see if maybe it could make things easier for them, but none of these methods proved to be more intuitive than the first one that we had. We opted to leave the design as is, and if a certain child did have trouble rotating the piece while moving it, we would allow their parent to press the rotating button for them whenever the child asked them to. There was one other issue that became very clear during these pilot tests. There was actually a bit of dead space around each of the shape, so if they were close together, you would go to click on one and accidentally click the one beside it. This meant that all of the puzzle pieces had to be remade from scratch, making sure to eliminate all of that dead space so that there could be precision when you were clicking on a specific puzzle piece.
Now that I've talked about the changes that we had to make after the pilot test, let's get back to the main timeline where at this stage I had essentially built the whole website, but it was not hosted online anywhere.
At this stage in the development, the website was fully operational, but it was only accessible to me. It lived on my hard drive, and it referenced a bunch of other program files and image files that were all located inside of the same folder. So the next step was to find a way to host it online. I researched a number of different hosting companies to try to find which one best towed the line between not being too expensive, but still meeting the requirements of our ethics committee.
Luckily, before we settled on any particular option, the Department of Psychology at Concordia purchased a license for Pavlovia.org, a website that is specifically designed to securely host psychology experiments written in HTML and JavaScript. I made a number of modifications to the website's structure so that it would be compatible with Pavlovia's servers, and successfully uploaded it to their system. Today this website is fully operational and is being actively used for data collection.
With the first challenge conquered, we moved on to the second one, figuring out what the best way to interact with families was while they complete the experiment. The pandemic had opened our eyes to the possibilities afforded to us by Zoom, and we realized that we could run the whole study on a Zoom call. Specifically, following recruitment, families would meet with our experimenter on a Zoom call, and after giving their consent to being recorded, we would start a recording. They would then navigate to the website, and as they completed the puzzles, we would be obtaining behavioral and audio recordings of what they were doing, which could later be transcribed and analyzed exactly like we would have in a traditional lab setting. This project successfully overcame the challenges of recreating social experiments in an online setting, and benefited not only this specific project, but also created knowledge, skills, and expertise that could be reused for future research questions. Online psychology experiments do not have to be limited to questionnaires, reaction time tasks, or more traditional data collection methods. This project is an example of how social development research can be run remotely and unexpectedly highlights some of the benefits of conducting research in this manner. We have found that not only is it a safe way to conduct studies during a global pandemic, but it is also easing the experience of participating in research for families. They do not have to leave their homes to participate in research, which removes some of the barriers to research participation. Busy work and day schedules, travel time, and general commitments can all decrease the likelihood that a family will participate in research. By running the studies remotely, we have found that more families agree to participate and less families miss or cancel their appointments. These benefits, taken together with the fact that an experimenter can run a study from any private place with an internet connection, has led to some of the most efficient data collection in the history of our lab.
Of course, online data collection is not without its limitations. Connectivity issues and suboptimal home environments for testing have created a source of data loss that is not present in traditional lab settings. Our website is not functional on mobile devices, and this has been an issue for certain families who primarily use tablets to browse the internet as opposed to computers. Despite online data collection opening doors for certain families who would have otherwise not participated in research, it can also serve as an impediment to research participation for other families. These families may not have the proper technology at home for online research, and not offering the chance for in-person participation may systematically exclude them from our samples. The potential for an online, in-person hybrid research design should be considered for future studies. I would like to thank Maxine Ionicelli for all of her help and for allowing me to share some of her work with you all. I would also like to thank Dr. Dunfield for her guidance and support throughout this whole process. Finally, I would like to thank Dr. DeLu for making his excellent programs freely available to the general public.